In this section, we're going to be looking at midsurfacing and how we can use it to reduce the nodes and elements for structural analysis. Let's start by opening up our midsurface assembly. Here, we have a group of solids which are all thin plates. Now, in order to start midsurfacing the part, we're going to go to our Prepare tab and click the Midsurfacing button. And you'll notice on the left side of the screen there's a lot of options for midsurfacing, as well as tool guides. We'll look at explaining these different options and show how you can use them to extract our midsurface. To start with, it says select a pair of offset faces. Now on this model, notice if I hover over the faces, it only lets you select faces which have an offset of each other. So in this green part on the bottom, the only two faces as an option are the top one and the bottom one. So it automatically filters these faces into your selection. I'm going to select on the top face, and now notice I'm going to try to select on the bottom one. It only lets you select faces which are offsets, which is only this bottom face, and I can just click it to select it. Now before I do, I want to call your attention to our select options. Notice that it says use selected faces and use range. The default range is from 0 to 5 millimeters. But as I click on this second face, notice it changes. Our minimum maximum thicknesses will change depending on the midsurface which you are selecting. For example, if I select on the front face of the purple and then click to select the back one, notice it's automatically filtering through the model and selecting the back face. This changes to 12. Usually the first thing I do when I bring it apart is I'll select a few offset face pars to see which is the minimum thickness and which is the maximum one, to give me an idea of what I'm doing in my assembly. Now, as I select faces, when I'm ready, I can click the check mark, and you notice that extracts the midsurface between these bodies. Now it's temporarily going to show the midsurface as opaque and blue. When I click in white space, it hides the solid and creates the midsurfaces as transparent entities. Now I also want you to notice that it extended the midsurface as it did this. So if I undo once, I'm going to extract. Let me zoom in first. I'm going to extract those two, and notice it automatically extends this midsurface down. Notice we have an option to extend midsurfaces. If I undo, turn off extend, notice it just extracts them and leaves them exactly where they are. But it's typically a good idea to extend it so you can have a nice connection between those different solids that are there. Now let's undo back. So far we've explained a few of the options. Let's also take a look at grouping midsurfaces, an active and same component. In this model, all of our solids are at the top level. They're not inside of components. When I create a midsurface, notice it's grouping them. I'll hit the check mark. What it means by grouping them is it puts all the midsurfaces into different components that are there. And if these were inside of components, the midsurfaces would go into the same component or in the currently active component. So the currently active component right now is this top component, and also all of the solids are in the active component, and they're placed there as such. Now, I'm going to undo. I typically prefer to turn grouping midsurfaces off. What that does is when it extracts them, it puts them just as surfaces at the top level. I find it's easier to work with the midsurfaces when they're ungrouped, but again, that's a personal preference for you to decide after midsurfacing a few models. Now I'm going to undo again and turn back extend midsurfaces on. Now the next thing to look at is using our selected faces in the range. If I start to select a few of these midsurfaces, see that I have a generally good selection for a range, I'm going to click in white space, turn on use range. And if our mid-surfaces have a minimum thickness of this and a maximum thickness of that, typically I'll make it a little bit less and a little bit bigger, just to make sure that I have all of the faces in my selection. Now, when I use arrange, I'll simply make a big box select and grab all of those faces. And now you'll see that it identifies all of these parts automatically. So if you have 10, 20, 100 parts, using arrange is a much faster way to extract all of them. Now, I can click the check mark and it will extract all of those mid-surfaces at the same time. And because they were not being grouped, you can see them all in the bottom of my screen. Now, the only other thing that we might want to do is check to make sure we actually have a nice connection between these. Now, the way we'll do this is we'll use show contact. Now, I want to point out that when I try to show contact, a warning message pops up and says, "No parts have shared topology set to true." So in order to set that to true, we'll select on our top level mid-surface assembly, and our top option and our property is shared topology. I'm going to set that to true. And what that will do is it will show us where parts have good connections. So the laminar edges show free edges that are there, which are not touching anything else. The edge junctions show where we have edges on one model that touch or pass through the surface of another. So here in this model you see that we have nice contact between all these surfaces, and we'll get a nice mesh when we go into our mesher. Now the next thing we'll look at is a single part. So I'm going to go to open and open up a mid-surface of a part, number 2. Here we have one single solid. And I'm going to start using mid-surface and select a pair of offset faces. So I'll click on one face, and notice it only filters in faces which are behind it. So to start again, if I chose this face here, any face which is an offset, which include these faces up here, are selectable. So typically, you'll want to just select on a face right here to identify all those faces with the same thickness. Now in this model, you'll notice that almost all of these faces are identified as having the same thickness, except for a few areas down here. Now when we mid-surface a part, we mid-surface from the blue inward and from the green outward, and we just get rid of anything which is a duplicate. If these mid-surfaces don't match up with each other, we can add in those faces. We can add or remove faces into our mid-surface. So I can add them in from one side or the other side. When you add faces in, you should only add them in from one side. The reason for this is, like I said, if this face and this face are exactly the same and match up, we only put one face there. With these faces and these rounds not matching up with the one on the other side, we're going to get two faces there. If you know which side you want to offset from, only select the faces on that side. And once you have all of the faces selected, click the check mark and create that mid-surface. Now you'll notice that when I mid-surface this part, we can see the thickness that's there temporarily. Makes the solid transparent, makes the mid-surface opaque. But you'll also notice that I have two mid-surfaces in the tree. I have our big surface and this little one that's here. Let's look at why we have this little surface created. I'm going to hide these and turn back on the solid. Notice this face on this side is different than the face on the other side. So because of that, notice it made that extra section like I was saying before. If the faces are not the same, we'll create an extra surface because we don't know which one you want. You could want one, you could want the other. So in this case, we'll simply right-click and delete that extra mid-surface. So So I hope you've seen different ways that you can extract midsurfaces on both assemblies and parts in this section. Thank you for watching.